So, do Parsers dream of electric guitars? Hello, my name is Ju. I like to play the guitar. I'm not very good at it, so I have to look up songs on the web. But those webs are dark and full of terror. So usually, I'm looking for a song like in this form. So there's like some lyrics, some chords, they all like jumble together. And my goal is to be able to look at something like this and play it. And maybe sometimes I won't know the chords, so I have to look them up, right? So this is what I'm looking for. But normally, the websites that have such content, they look something like this instead. And I'm not joking, they have like auto-playing videos. It's 2019 and they have auto-playing videos. So really, I'm like, okay, fine. I'm a software engineer. I'm sure I can do this myself. So I have a bunch of slides, but I've decided I'm not going to use the slides. And instead, there's going to be a lovely terminal. Okay, cool. So I'm going to create this thing in Elm. So I'm going to use what I call the Harry Potter technique. So what I don't have, I'm just going to atcho it. So I'm going to do atcho Elm. Awesome. And you see I have this lovely Elm program here. And if you've never seen Elm, if it's like your first time looking at something that looks like, functional, statically compiled, whatever, it's fine. Don't worry about it. We have a main, and this is the entry point of our application. We have a very simple view function, which takes a model and emits something which is HTML-like. And then we have an update function. We won't even touch the update function, so you don't have to worry about that at all. But if I have something like this and I save it, I have a little bit of machinery that will recompile this and show it in the browser. So I'm going to make this bigger. Hello world, OK? And if I change world, if I just say instead of world, I'm going to have, oh my God, this is tough to type. I'm too tall. And if I do that, you'll see it will automatically refresh, and we'll see the changes there. Perfect. So let's start. The problem which I stated is that I have this sort of sheet. So I'm just going to atcho it. And you see, this thing is a string. And it's all mumbled together. As I said, we have the chords, the lyrics, and it's all mixed up, right? So as programmers, when you see this very easy task, we're like, I know something, I know regular expressions. And regular expressions are very good at parsing text, or so I've been told. So I'm going to do that, but I don't really want to subject you to the pain and suffering of having to watch me type a regular expression. So I'm going to atcho that as well. And you see, even if you don't know what a regular expression is, I'm just going to quickly explain it. We're looking for chords, and the chords can be A, B, C, D, E, F, G, sorry. The chord can be a minor chord, and this is what this optional M does. Or otherwise, we can have some lyrics. I won't go into detail how that works, but just trust me, it does, right? Once I have this regular expression, I can grab my sheet, I can split it into lines, and run this regular expression on it. Right? So I'm going to do that. I'm going to say that I have some lines, and lines is going to be string lines of a sheet. Awesome. And then inside here, I'm just going to do a little bit of rework in there. I'm going to map over the lines. And I'm going to say for each one of these lines, I want to create a div, because HTML is real programming. So we have, just wanted to put it out there in case people think, otherwise of it. And I'm creating a div. Inside each div, I'm going to put a span. Inside that span, I'm going to put the line as a text. And I'm just going to add a little CSS attribute. So I'm going to add a CSS class to this and just call it line. OK? And you'll see, there's some errors. You can see because my editor is red, right? And the error is, there's some naming error. I cannot find a regex type. I cannot find a regex import. And probably, and it also gives you some suggestions of what sort of things it could be. Unfortunately, it's none of those. I just forgot to import a regex package. So I'm going to do that. I'm going to say import regex. Sorry. OK, this is living life on the edge, but it's good. So once I've done this, you can see that there's no more errors because the red from my terminal has disappeared. And this is usually how I tell if there's an error. And you can see that here, where we're printing the line, here's the line. Amazing. But now I really want to run a regex on this thing. So I'm going to do regex. And regex accept a find thing. I can pass the regex. I can pass a line. And this regex function returns something a bit weird. It's like a list of regular expression matches. So I don't want to bore you with that. I'm just going to say, I'm going to pipe this function called view regex. And I'm going to quickly atcho it. Atcho view regex. Amazing. This is like such a nice way to do programming, by the way. Like if you've never tried it, it just feels so good. And if I inspect the generated HTML, you can see that I've created these little token classes. And basically, this is like what the regular expression has been able to extract. So you can see the first thing has actually been able to recognize that A minor is a chord, and it's there, right? So like if I was, like in my normal daily job, I'd be, oh yeah, I'm done with this, like problem solved. But not really, because now we have a program that's able to understand some text, but actually, like, does it really understand text? Like, we sent like this string, and this program was being able to sort of, do some weird stuff with it and return to us a list of tokens, which are just strings. But it didn't really recognize what chord is there, right? Like, if I want to ask the program now, well, how would you play an A minor on a guitar? The program would be, yeah, I don't know, there's a string there, you told me there's a chord, you do something with that, right? So usually we'd have to write some other code that grabs where I think there's a chord, and then try to figure out what the chord is. So instead of doing that, couldn't we write a program that does something very similar to what the regular expression does, but doing all that part of the work for us as well? So the answer is yes, and we're going to do that. We're going to use a library which is called Parser. So I'm going to import parser as p. Just because I don't want to qualify everything, I'm just going to import everything unqualified. But this is only for presentational purposes. You should never do this. Do it. And instead of running a regex, I'm going just like to write a parser, right? So I'm going to say, I want to create a chord parser. And this thing is a parser of a chord. And this is what I call like the beauty of like functional programming with types, is that you're sort of, just like, it's like Saturday evening with you're with your friends, and like you don't really know what you're talking about, but you're just saying stuff. You're like, yeah, I'd like to have a parse of a chord, and someone was like, well, what's a chord? Like, oh, good question. And we don't know because we have no idea. Like, we're just thinking, okay, I need to parse a chord. There must be a chord there somewhere hidden, right? So we just need to define this. And I'm going to say that the chord is just that. So it's going to be a chord. And this is like what we said before, that actually the thing on the left and the thing on the right are different things. Don't bother about that. But just think that the chord, what are the, the key defining features of a chord? There's a note, which is the root note. There's like a type of the chord, whatever, right? So I'm going to say there's a note, and I'm going to quickly atcho the note. And you see, like, these are the same notes we said before, like A, B, C, D, F, G. And actually now I think, okay, I want to distinguish between major chords and minor chords. So I'm going to add another variable, which is going to be a quality. And here I'm going to say that the type of quality is going to be either major or minor. OK? And amazing. What is the error? There is a type annotation for type parser, but there's nothing. Oh, do something. Like, say that it's just 42. OK, easy enough. So here I'm going to do something a bit silly, which is instead of building a real parser, I'm going to build a very dumb parser that always returns A minor. And I love the chord, so like there's no other reason for that. So I'm just going to say p succeed, and this is like how you return a value. And I'm going to say always, no matter what, return chord A minor. Okay? And here I'm going to, just for the time being, cheat a little bit. And instead of using the whole thing, I'm just going to use some simple chords. So I'm going to say C, I'm going to say F, and I think that's enough. And instead of running the regular expression, I'm just going to say case p run of our chord parser. And I'm going to run it on the line. And this thing returns a result, which is either OK and a correct result or an error. So this is like a neither in Haskell. So when it's OK, we'll have a value, and I'm going to say HTML text, and I will debug out these values. So something like this. Or instead, if it's an error, I'm going to say this is an error. And just for now, I'm going to say, OK, well, debug this thing as well. Error. Cool. Amazing. Ta-da! So we passed like these 3 strings, and our amazing parser just said, trust me, mate, it's just like 3 A minors. Yeah, I mean, this is pretty cool and all, but I would rather have a parser that actually, can really parse stuff. So let's do that. So you see, like, this code has these 2 components. One is the note, and the other one is the quality, right? So it would be really nice to have something like this. So I would really like to have a function that passes me a note and a quality, and I can just do chord, note, quality, right? Incidentally, whenever you're defining a type in Elm like this, the data constructor is automatically created for you. So instead of like writing this thing, I can just say chord, and that's exactly the same thing. And now basically I have to do these 2 things, right? I have to say that I want a sort of note parser, and I also want a quality parser, right? But there needs to be some sort of syntax that says, grab this note, pass it up, grab this quality, pass it up. And what the parser library exposes, and this is like one of the few cases in Elm where there's like this, like a special operator for doing something. And I call it the human funnel operator because it's a pipe equals. So it's just, this guy. This is one human funnel, and then I'm going to add another human funnel, and there you go. Like, this is more or less what we would like, right? We have just combined 2 other parsers into our core parser. So we have something that picks up a node and something that picks up the quality. If I save now, of course, it's going to tell me, well, there's no such thing. Like, I cannot find a node parser. So we're just going to define them. So I'm going to say that the node parser is something that's called a one-off. So this is basically used when you want to provide some alternatives to the parser. You say, OK, either do this, or do that, or do something else. And I'm going to say that you want to succeed with A, and this is the note A. Whenever you pipe dot, this is like what I call like the little like watch pocket operator. Just grab something and you put it in your pocket, but you don't even pass it up. You can be quite, capitalistic about that, I guess. And you just grab the symbol, which is note A, right? So basically, this is something that consumes something and pass it up, and the pipe dot is something that consumes something and just, keeps it. And we want to do this for all the nodes, so just like write like a little snippet that does that. So node G, well, so the last one, node C. Perfect. And this way, we've defined our node parser. It can either eat this and return this, eat this, return this, eat this, return this, eat this, return this. 10. Perfect. OK, so now that we're done with that, we're going to define a quality parser. And the quality parser is very similar. It's still going to be a p1-off. And it's going to be a p-succeed of minor whenever we watch pocket symbol lowercase m. And then we have the case where we have a major chord. And a major chord is just a capital letter. That is like, there's nothing else, right? So basically, the way that we can express that is just say, if you can try to match the minor. If you can't match the minor, just succeed with a major. So we're exactly doing this, right? Cool. And I'm just going to add it in, and that's it. No more red. It compiles. It works. Yeah? So we wrote like a parser. The parser now is actually able to recognize an A minor, a C major, and an F major. And these are actually types. So the computer knows a lot about those things. Like, it's not just text anymore. But before I cheated, right, I didn't really use the initial string that we had. I used like this like little trick. So instead, we're going to write something which is a line parser. So, and this parser will be able to parse the whole line. So it's going to parse this whole line and return to us a list of tokens. So I'm going to write this and say it's a list of tokens. Still, as before, I have no idea what the token is. So probably I can define a token like it's either like a parsed and it has a chord, and this is like the same data we defined before. Or we can say it matched some lyrics, and this is going to be just a string, right? And if I do that, I can just say, just as before, P1 off. And here I'm going to succeed with a chord. And as we can see in our sample, the chord is delimited by these square brackets, right? So I'm just going to write that in the parser. I'm going to say that whenever you can match and keep a symbol which is open square bracket, I'm going to paste that down and replace it here. And the thing in the middle, that's just our chord parser, which we just wrote. Okay, so this is the case for when the parser is able to recognize the actual chord. There's also the case where the parser needs to recognize the lyrics. I don't have much time, so I will just grab some code there. I'm happy to explain later how this works. It's mostly about looking ahead and trying to do some interesting stuff. Actually, this is going to be parsed. Awesome. And I wanted to show you this, and it's red and it's bad, but no, it's okay. And the reason why it's okay is because we did this, right? We wrote something that's supposed to return a list of tokens, but Elm tells us, no, you just return something that returns parser token, right? So definitely we forgot that we were supposed to go through and keep parsing this line, and we just returned a single thing, and Elm just tells us, oh, you made a mistake. So we're going to fix this mistake, and I'm just going to use another helper inside the library, which is called loop, which, as you can guess, it loops. It takes an initial value of the accumulator and a helper function, which I'm going to call parser helper. And this parser helper is basically exactly the same function we wrote before, except that instead of returning these parsed things, it needs some extra information, basically that the library uses to know if it has to keep looping or not. But it's very simple. So I'm just going to say, if you get a value and it succeeds this parsing operation, you're going to keep looping. And you're going to keep looping over this thing that you just parsed, and I'm going to add the accumulator, right? And then I'm going to do the same for the lyrics. So I'm going to say, if you manage to grab some lyrics, just do keep looping. Loop, cool, lyrics, v, ac. Awesome. And then the final case is that if the parser cannot do either of those things, it just means we're done, right? So in this case, I'm just going to do succeed. And now the special value is going to be done, which means you're done. And here I'm going to reverse the accumulator, because we've been adding things in front of it, so we actually need to do that. And you'll see when I do this, I made a mistake here, and Elm will tell me that I typed succeed, but probably I need succeed with double E. Actually, I can just say, all the mistakes I've made in this talk are just to showcase the compiler errors. Prove me wrong. OK, cool. So here we have this thing. I'm just going to replace here, instead of using the core parser, I'm going to use our line parser. And instead of this cheat, I'm just going to actually uncomment this line of code. I've just also made it a little bit nicer. So instead of having to pattern match manually, I'm just going to call this other function. And I'm going to acho that as well. Acho view result. Awesome. With that done, ta-da. So you can see the end result is not that much different from the result with the regular expression, but it's so much more. So now, actually, Elm knows what is a chord, what are lyrics, what is a chord, what is lyrics. And with this information, you can do a lot. What I mean by that is that, for example, nothing could stop you to write a library that is able to define a lot of different types of chords, right? Can you, oh, sorry. And there's I've just learned on Wikipedia, there's a lot of types of chords apparently. And each chord has also recognized mathematical notation, which is called integer notation. And so you can basically transform any chord in a list of offsets from the root node. Not only that, once you have that, and you have this representation of this offset, you could represent a guitar in Elm and have some code that basically, I don't have to go into the details, but you can see like these 4 lines of code. It's taking a chord, it's looking at the possible ways you could play this chord on a virtual guitar. It's going to look at which combinations are ergonomic for a guitar player, and then it's going to sort them by some sort of index, right? And it looks just like so nice, right? Like it's like most of the times, like when I'm saying, okay, how do you play an A minor? You'll have to hard-code that information somewhere. But as soon as the computer knows more about that, then you can do like so much more stuff. So I've published the library on GitHub, but I just wanted to show you, this is a platform called Ellie, and you can have, and this is like all the code on the left, and on the right-hand side is the result. So it's like these 200 lines of code. And I've integrated this web audio API library. So basically now when I hover on a chord, you can see that this all is computed like on the fly. There's nothing hard-coded. Like the only input I gave to the program was like the same thing you've seen before, right? And now the program is able to say, okay, you want to play a G chord. I know how to, like what a G chord is in musical theory. I know how a guitar works. I know how you mean like that the chord is ergonomic for a guitar player, and so on and so forth. And now that, for example, I've integrated the web audio API, means like I can also play it. And what I think is really cool is like, for example, if you look at the C chord, the first dot, the one here, that's the C note. That's the root note of the chord, right? And it happens quite a lot when you're playing guitar that sometimes you want to change the root note. So for example, this chord is a C/B, which means it should be a C chord, but change the root code from a C to a B. And this is exactly what the code has done, right? But I didn't really have to explain to like where to look, or there's no if conditions. I just told him, if you do that, then you just need to readjust a bit the integer notation. But then all the other things apply. Yeah, one more thing. So this is it, and I'm going to need someone's help just for a few minutes. Maybe someone? Amazing, Chris. So I'm going to go through this song, and I just need you to press like the right arrow like every time like the end comes. Yeah? Yeah? Perfect. Or even space works. Okay. Yeah? I think it should just work. Yeah. Okay, go for it. Okay. Some errors are really bad. They can really make you mad. Debugging just makes you swear and curse. Please join me in the chorus, by the way. When you're chewing coal stack gristle, don't grumble, give a whistle, and Elm will help things turn out for the best. And always look on the bright side of types. Always look on the light side of types. If your code seems jolly rotten, there's something you've forgotten. A parenthesis, a bracket, quoted string. If you're getting a chord dump, don't be silly chumps. Just purse your lips and whistle, that's the thing. And always look on the bright side of types. Always look on the light side of types. For quoting's quite absurd, and that's the final word. You must always face the curtain with a bow. Even if you're stuck in Vim, give the audience a grin. Enjoy it, it's your last chance anyhow. So always look on the bright side of maths. Just before you reach your last effects. My life is in a tweet, when you look at it. Laugh's a laugh, and that's the joke, is true. You'll see it's all a show, but please stop writing go. Just remember that the last laugh is on you. Always look on the bright side of types. Always look on the light side of types. Always look on the bright side of types. Always look on the light side of types. Thank you so much. So I've put like everything here, and you can also play around with the code snippets. So for example, like in this bit, like if you want to change the lyrics like to something else, like it's just a string, so you can just replace everything and play around with it. Yeah, thank you so much.